2, and we can go over how I want you to work the figures on the science and reasoning section. So as I've said about the reading section, reading is the last thing I want you to do when you work a passage. That goes double for the figures and tables that we're going to see in a science and reasoning passage. Take a look at the passage we see on 572. You're going to notice a lot of text in 2 tables. Ignore the text. Instead, we just want to focus on the tables and figure out what information and what patterns we see there. So let's start with the variables on table 1. What are we observing? What are we recording?
I see velocity.
Anything else?
Radius and frequency.
Radius and frequency. And what are we measuring the speed of?
I don't know.
Exactly. We don't want you to read the passage. It could be race cars, it could be electrons, it could be meteors hurtling towards the planet Earth. But really, we just want to focus on the patterns and trends. And if we need to know more about the experiment, we can go back and read the relevant sections and answer specific questions. But first thing we want to do is understand the variables and any patterns that might be informative for working the questions that we see on page 573. So let's start by looking at the trend in each variable, and what do we notice is going on with velocity?
It seems to be increasing by 500 every time.
Yeah, so we notice that it's increasing, so we've got a positive relationship. What about radius?
It also increases with velocity.
Yeah, so we see these two are going up at the same time, so frequency is also going up?
No, it seems like it's the same. Yeah,
All
it's
right.
all the same.
Yeah, so that we have a flat relationship. Or a constant relationship. So we can hold on to these 3 as is. All right, now let's look down to experiment 3 and table 2. And instead of figuring out what the experiment is, we can notice what changes and what data is being presented by, again, working the table. So what variables do we see on this table?
Instead of velocity, it now has magnetic field strength?
Yeah, and is that going up or down?
It's going up.
It is going up. All right. So the other variables are also the same then?
No, yeah,
So
radius and
radius.
frequency.
So radius and frequency are there, and I'm assuming the radius is also going up with the magnetic field strength?
No, it's going down.
All right, so that's going to be a negative correlation.
But frequency is going up.
Oh, and here I was hoping it would stay flat again. No?
No.
Ah, darn. All right. So here we see not just changes in the variables, but we also see that the trends or the relationships between these variables are changing as well. It's also nice because we notice that radius and frequency are staying the same. I mean, they're the same variables, but they're doing different things than they were in experiment 1 and table 1. But with this information, we can start working through the most basic of questions, such as question number 18 on page 273. Alyssa, can you please read that question for me?
On page 273.
Yeah, just flip the next page over.
Okay. Number 18. Based on the results of experiment 1, if an electron were shot into an cyclotron with a velocity of 5,000 ms, the radius of the orbit would most likely be.
All right, so which table do I want you to look at then? Table 1 or table 2?
Table 1.
Yeah, and there we see both velocity and we also see radius. Notice that we don't have velocity in table 2. So what radius do we see at 5,000 meters per second on table 1? We don't, do we?
No.
No, but we can actually use the information that we already worked through on this table to come up with a good approximation. So let's look at 1,000 meters per second velocity, and what's the radius for that?
5.7.
5.7, good. Now let's double the radius to 2,000, and double the velocity to 2,000, and what does the radius change to?
11.4.
Is that double of what we saw for 1,000 meters per second?
Yeah.
Yes, it is. Now look at the last one, 2,500 meters per second, and what's the radius there?
14.2.
So if we double the velocity, should the radius double as well?
Yeah.
Yeah, so what would the radius be in that case then, if we doubled it?
28.
28, just a solid 28, so 14 and 14?
Well, no, it'd be 28.4.
Yeah, this is the 14.2, good.
Okay.
So we look at the, if we're calculating that, what answer choice is closest to 28.4 then?
H.
H, correct. And with answer choice H, we get exactly 28.4, showing if we work the figures efficiently, we don't have to complicate our lives working through a passage and get all the information we need for some of the most basic questions. Good work, and that wraps up these videos.